All right, so in the first part of this lesson, we talked a little bit about why I might want to use an absolute value inequality, or at least what that represents. So we put it in the context of a more real-life situation, just to see what was going on. In this part, we're going to look at how to actually solve the problems that you're going to see in your book, and then again on your review and test. So absolute value inequalities come in two flavors. The first flavor is problems that deal with less than and less than or equal to. Now, I know right now you're not going to understand why there's a difference, but hang on and you'll see. So everything I deal with for right now is going to have a less than or equal to in it. So here's a problem. And this is the simplest one I can think of. The absolute value of x is less than 5. Now, what I want to do is really understand what this is saying. Remember that the absolute value is the distance away from 0. And I'm saying something about being 5 away from 0. So remember that there's two ways to be 5 away from 0. I can be 5 to the right, or I can be 5 to the left. And everything that is in between 5 and negative 5, well, let's take a number, negative 3. That's within 5 of 0. 4. That's within 5 of 0. And remember, this problem is saying I want to be less than 5 away from 0. And anything in this range right here is less than 5 away from 0. And everything on the outside, out here and out here, left and right, is not less than 5 away from 0, like 6. 6 is more than 5 units away from 0. And 8 is more than 5 units away from 0. And on the left-hand side, negative 10 is more than 5 units away from 0. But everything in the middle is less than 5 units away from 0. And so that's what this problem is saying. Now, in general, absolute value problems are usually broken into two different problems, right? Because there are two ways to be that distance away from 0, and this is no exception. So in this case, the solve is instantaneous. There's no work to do. The value of x must be between negative 5 and 5. Any x value that is between negative 5 and 5, and here's the algebra, here's the picture of being between negative 5 and 5 right here. Any number that's between those two satisfies the idea that I am less than 5 away from 0. So if x is not between 5 and negative 5, say if x is negative 10, I am not less than 5 away from 0. And likewise, if x is 6, which is not between negative 5 and 5, if it's out here, I am not less than 5 from 0. So that's the idea. So let's look at a problem that's a little bit more realistic in terms of what you would see in your work. So number 2, let's do the absolute value of x plus 2 is less than or equal to 6. Now again, think about what this is saying. Absolute value means distance away from 0. And I'm talking about being 6 away from 0, and there's two ways to do that. 6 and negative 6. And I want the distance to be less than 6 away from 0. Well, 1 is less than 6 away from 0. 2 is less than 6 away from 0. Negative 3 is less than 6 away from 0. And in fact, everything from here to here is all less than, and I shouldn't forget the equal, less than or equal to 6 away from 0. Then everything out here, 7, 8, 9. Okay, that's not a 9. 9. And negative 7 and so on. All the stuff out here is more than 6 away from 0, not less than or equal to. So we'll break it into two problems. X plus 2 has to be between 6 and negative 6 in order to be less than 6 away from 0. And again, this is the algebra of that. This is the picture of that. So then what about x? Because I know about x plus 2, I don't know about x. So you just want to solve this in the usual way. Minus 2, minus 2, minus 2. And if I do all that, I should end up with negative 8 less than or equal to x less than or equal to 4. And there's the algebra of my answer. And understand what that's saying. That's saying if I took any number between 8 and 4, negative 8 and 4, and let me just pick one. So something between negative 8 and 4. Okay, negative 2. And I substitute into x, and let's see what we get when we do that. So we've got negative 2 plus 2. Well, that's a 0. And the absolute value of 0 is 0. 0 is less than or equal to 6, so it works. And then I can also make a visual of this solution, which some of your homework problems might ask you to do. Very easy. Here's 0, here's 4, here's negative 8, and my answer is between those two. There you go. So this is your graph, and this is the algebraic solution. So we have the algebraic solution and a picture of the solution. And so those are your less than and less than or equal to. Now, this will be a little clearer when we do the other type. So let's add a slide. And this is flavor 2. And flavor 2 deals with greater than and greater than or equal to. So these are a little bit different, but same idea. So again, let me start with the easiest thing I can think of. Absolute value of x greater than 5. And again, let's think about what this means. Talking about absolute value, which is distance away from 0. Two ways to be 5 away from 0. I can be at the positive 5 side or the negative 5 side. And this has a greater than. So I want to be more than 5 units away from 0. Well, 2, 3, those are not more than 5 away from 0. Negative 1, negative 2, not more than 5 away from 0. But 6 is more than 5 away from 0. 7, 8. Negative 10 is more than 5 away from 0. In this case, my graph is going to look like this. These are the things that are more than 5 away from 0. So again, this breaks into two problems. Problem 1, x could be bigger than 5. That is one way to be more than 5 away from 0. And that right there corresponds to this piece of the graph. And the other option is x could be less than negative 5. Now, why less than? Well, when I look at the graph part of it, I can see less than goes to the left, and less than negative 5, you can see that I am, in fact, smaller than negative 5. That captures the negative 6, negative 10, which are all more than 5 away from 0. So again, a problem that would, that's a little simple, so a more realistic problem. X plus 2 absolute value is greater than or equal to 1. So here again, I'm trying to be more than 1 away from 0. So there's 0, there's 1, there's negative 1. This is more than 1 away from 0, and this is more than 1 away from 0. So two problems. X is more than 1, x plus 2. X plus 2 is more than 1, that captures this side of things, or x plus 2 is less than or equal to negative 1. That captures this side of things. Solve in both cases by minusing 2. X is greater than negative 1, or, sorry, I forgot my 2 there, minus 2 minus 2, x is less than or equal to negative 3. And there's my solution, and again, we can graph it. There's the 0, negative 1, negative 3, and greater than or equal to negative 3, or sorry, less than or equal to negative 3, greater than or equal to, 1. Sorry, I kind of lost my line there. And there's your poor, but your graph nonetheless. And there's your solution and graph. If you have any questions, as always, please see me in class.